Today we're going to take a look at this new memory board. It was designed specifically for early S-100 systems where the memory space fragmentation in those configurations often makes it difficult to expand ROM and PROM as you really would like to. This board provides up to 64K of RAM and up to 32K of PROM space. The PROM is implemented on an EEPROM. However, the write line to that EEPROM is normally disconnected, so you don't have to worry about anything starting any accidental write cycles to that EEPROM. However, there is a switch over here that allows you to connect the write line. That, of course, then allows you to do intentional writes to program that part. Now, I have actually written a little utility that works pretty much like using an EEPROM programmer, so you can write code into that very simply. And of course, you don't have to pull the part out or have an EEPROM programmer to actually write it, so that's kind of handy. Now, in the top 16K of memory space, from C1000 through FFFF, this board allows you to enable RAM or PROM in completely independent 1K blocks. You can see up here I've got 16 switches. I don't know if you can read it, labeled C1000 all the way up through the top of RAM, top of memory space. That enables you to turn on and off 1K blocks for RAM. Corresponding 1K block switches are here for ROM. Now the next 16K down from 8000 through C1000, you can do something similar, but it's in 4K blocks. So here's the switches for RAM, here's the switches for ROM. As you can see, the switches are all on the top of the board, so you can get to these switches while the board is in place. And all the addresses that are affected are written right on the board, so it's very obvious what you need to do to enable the sections of RAM and ROM that you want. You shouldn't have to refer to a manual at all. And the on position of the switch turns on the RAM or ROM, off position turns off the RAM or ROM for that 1K block. So very intuitive. It shouldn't, again, have to use a manual. Now down in the lower 32K of memory space, I only have RAM on this board. And the address that the RAM starts at is controlled with these first 5 switches here. You can start the RAM on any 1K boundary, and from there it then fills up through the 32K mark through a hex 8000. This allows you to keep old vintage boards in your system, small RAM boards. For example, you could have a 1K board and a 4K board in your system down at 0, and have this board start at the 5K boundary with these switches and then fill from 8000 up. That way your vintage boards don't sit on a shelf collecting dust. You can actually keep them in your system. This board supports Phantom. It supports 2 modes of Phantom. One, it can block just reads during a Phantom cycle, or it can block reads and writes during a Phantom cycle. The reason for both options is because there are systems out there that expect one behavior or the other. So this makes this board more flexible. And then finally, there's also a switch that allows you to swap the 2 halves of the EEPROM. If you think about it, you'll probably never use a full 32K image in that EEPROM. However, by having the 2 halves swappable, you can think of it as 2 16K EEPROMs. That way you could have 2 completely different configurations in here, and with the flip of a switch, switch from one configuration to the other without having to pull and swap EEPROMs or without having to program something new. It also can help you when you're programming. If the machine you're in has hardware or PROM in a space that address that you want to write this, you can just swap the halves and keep going. So that's kind of a handy little feature. All right, so let's take a look at a couple demos and see how this board works in action. Let's say you were able to pick up one of these VDM1 video boards made by Processor Technology. This is the first video board made for S-100 machines. Now, it's typically sold as part of a multi-board set called Subsystem B. And there's some really cool software for Subsystem B, and that's what I'd really like to run in order to use this board and really see it run through its paces. Unfortunately, I don't have any of the other boards of Subsystem B, and without those, it's going to be very hard to run any of that original software. The main thing I need is the GPM board. That's the General Purpose Memory Board. It had a mixture of RAM and ROM on it that supported the monitor that all Subsystem B relied on. It was the primary user interface to get everything going. That monitor was called Cutter. It included some RAM for Cutter to use, and then it also included 8K of PROM up in top of memory for their assembly language development system called ALS-8. And that's kind of chopped up, and it's kind of hard to do with any of the RAM cards I have. But with this new RAM card, it's going to be fairly easy. So of course I will program Cutter into it, as that's PROM, into the EEPROM. I'll program ALS-8 into it. and then set the switches properly to do exactly the memory allocation that we have on the GPM board. So let's go ahead and set that up and see how that is configured. The cutter monitor requires 2K of PROM space starting at C1000. So we'll go up here and we'll enable PROM at C1000 and at C400. That's the 2K for that. Cutter then expects 1K of RAM at C800. So we'll come over here to RAM and enable C800. The video board, the VDM1, its RAM, 1K worth, video RAM, is at CC100. So we need to make sure that CC100 is off for both RAM and ROM because that's where the video board is set. All right, ALS8 resides in the upper 8K of memory or ROM space on that GPM board. So that's going to be from E1000 all the way up through FFFF. So let's go ahead and enable that. So now we got ROM from E1000 through the top of ROM, memory space. That's ALS8. All right, and then ALS8 expects at least 1K of RAM, preferably 4K, at D1000. Now, the GPM board does not have that RAM on it. They told you to put in a 1K board or a 4K board. Now, I only have one 4K board in my possession. I haven't collected many old boards, and it's hardwired down at 0, so I don't really want to use that. So I'll use this board's RAM up here at D1000. We'll enable D1000 up to E1000. So I've got the 4K of RAM at D1000 that ALS8 requires. All right, now down in low memory, you're going to need some RAM for all the programs you're going to load and run. Again, I'm going to stick my 4K board down there just so, again, it's not sitting on the shelf. So I want this board to start its RAM at 4K and go on up. So you can look at this little chart here on the side, and I want up, up, down, up, up. So I just need to put switch number 3 down. I'm trying to do this without getting my hand totally in the screen. All right, so now this board will start at 4,000 and run up RAM through the 32K mark, 8,000. That's probably plenty enough RAM. That's as much or more than anybody would have had in the day. So now this board's ready to go to replace the GPM board that was part of Subsystem B, and we should be able to run Cutter and ALS8 and any program that would have run under Subsystem B. All right, let's go ahead and take a look inside the computer to see what we're going to run this demo on. I'm running an Altair 8800C computer. Over here on the far right is a CPU and front panel interface. Next to that is the memory board that we've been demonstrating, and it's configured like we showed, except for the fact that my 4K board didn't work. So this is going to do all of lower memory, including the 4K that I was going to run on that 4K board. All right, over here on the left is a VDM1 video board that we're trying to demonstrate. I've got a coax running over to a good old 9-inch monitor. Next to that is an AM radio that's going to pick up interference from the video board and give us some sound effects for a video game or a computer game I'm going to demonstrate. And then finally, I've got a solid-state music IO4 board in here that I'm going to hook to a serial keyboard to give us keyboard input. Now, Cutter supports both a parallel input keyboard and a serial input keyboard. Both of those are expected to be connected to their own 3P plus S interface board. P for parallel, S for serial. I don't have that board, so I'm going to do what I've done in a lot of videos. I'm going to take a solid-state music IO4 board and configure it to look like the serial port, in this case on a 3P plus S. So Cutter will be happy thinking it's got the serial port it was designed for keyboard input. All right, Cutter runs at C1000, so I'll examine C1000. That sets the start address. And now I need to tell Cutter what the output device is and the input device. It's done on the sense switches, kind of like you did with Altair software. Down here, these 2 bits determine the output device. 00 says it's the VDM1. These 2 bits determine the input device. 01 says it's a serial keyboard. Now I hit run, and we're up and running. Let's come over here to the monitor. This is going to be a little rough looking, I imagine, since it's a actual CRT. I'll try to pick a frame rate that'll get rid of beat patterns. All right, that greater than sign is the prompt. You can do typical things you would do in a monitor. I can dump a range of memory in hex. You can enter new values. You can execute from an address. Cutter allows you to load and save from cassette. Subsystem B included a cassette board called CUTS. It could run the standard 300 baud Kansas City standard, but also run at 1200 baud, which was 4 times faster, so that was nice. Now, I don't have that board. However, it is possible to load through the serial port on these computers. So that's a whole nother demonstration beyond the scope of this particular one. So what we'd really rather do is just see this video board working. Number one, you can see it working here with Cutter as our operating interface. Down at 0, I've loaded a program that was a popular program on the SOL-20, and since it runs on the SOL-20, it also runs under this subsystem B configuration. Most of the software can do that. This is a good shoot 'em up kind of game, which if you had been playing games on your Altair using BASIC like Craps or Lunar Lander or something, and then you put these boards into your computer and got to play this, you'd be duly impressed. All right, I'm turning on the radio, so we'll see if we can get these sound effects. I'm not sure if my microphone will pick them up. Go ahead and start the game. All right, so with the greater than and less than signs, I can move my my gun around. If I push space, it shoots, and then they explode. There's different types of targets going around. These are the main ships, the big ones. There's some little ones that go by that are very fast. I haven't seen one come out yet. But I'm going to shut up for a minute so you can hear the sound effects from the AM radio. It's unusual. I haven't seen any of the fast targets out yet. But anyway, you get the idea. So again, this would be quite a change if you were used to running basic programs. There's one of the fast ones. I just got quiet all of a sudden, my radio. All right, I can hit escape and just abort that. And here I got my prompt back for Cutter. So anyway, pretty cool game. There's a number of cool games, but it's not all just games. It's also things like ALS8, the assembler editor package. I can execute that by jumping to E060. Ready is the prompt for that. Oh, let me turn that game AM radio off. We don't need sound effects for the editor assembler. All right, so the ALS allows you to have assembly files. Here you see a short program. You can actually have multiple files open. They're all just in memory. I have a single file right now called test. It's a little assembly language program. It goes through a loop 20 times, and it takes the character in B and spits it out to the screen and then exits. So you can assemble that just with ASSM, and you actually give it the execution address in your assembly statement. You don't bother putting an OR again. So you can see it actually did assemble it at 100, and then I can run it at 100, and you see we get our 20 asterisks just like we expected. And then I can jump back to Cutter at C1003. That's the warm start address, and we're back to doing whatever we'd want to in Cutter. All right, so that demo works pretty well. I've got myself essentially the equivalent of subsystem B in terms of video, thanks to that board being able to, the new memory board being able to handle the GPM type requirements. All right, let's do one more demo, and then we'll move on from there. Next, I'd like to demonstrate the ability to swap the two halves of the EEPROM. We just got finished running Cutter and ALS8 from the top part of the EEPROM up in the top 16K of memory. In the bottom half of the EEPROM, I've actually got Altair's extended ROM Basic. And so I'm going to swap that into the top of memory so it's in its executable position. You do that here with switch 7. You turn off what's currently in the top and put the other one in the top. And now I have got extended ROM Basic for the Altair up in high memory, ready to run. Now, it requires all 16K in high memory to be EEPROM. So I need to turn off all RAM up there and turn on all 16K is EEPROM. So I've got C1000 through the top of memory, all EEPROM, all that RAM is turned off. All right, now it's ready to run. All right, let's go ahead and get this running. Quick look inside. We've got our CPU board and front panel interface. We have the memory board configured like we just showed, and then a 2SIO for console I/O. Very, very simple setup. All right, turning on and running ROM Basic is also very simple. Let's give it a reset. Examine C1000, that's the start address. And then here on the top 4 bits, we need to tell BASIC what kind of console port. 0 or 0001, tell it that it's a 2SIO. That's it, it's up and running. So obviously that's very quick compared to paper, tape, or cassette. And this is extended BASIC, which is very large, 16K, as opposed to the largest I think I've ever loaded for you online is only 8K. So here we have Altair ROM Basic, and it's got 31,700 bytes free. I only have 32K of RAM in this, so all but about 1K is available for user programs. So this truly executes from ROM. It does not copy itself into RAM. All your ROM, for the most part, is available for programs. This is, again, extended basic, so lots of features, but it doesn't support disk. So programs are loaded and saved with cassette. You would want that in an actual system, C load, C save. Just on a quick, interesting side note, this prompt right here, or the banner, Altair ROM Basic, and the copyright notice, that doesn't actually come out on any of the real ROM Basic boards that might have been shipped. This product didn't begin shipping until 1978, which was the year that Pertec actually canceled the Altair product line. So the ROM Basic boards never ended up in an Altair branded product. They went instead in something called the Attaché, which Pertec branded with the Icon brand. Now this string is still in the ROM, it's just that the A was changed to a 0, a null, so that when it went to print that, a null terminated string, it just immediately exited thinking it was done with the string. So that way when they shipped these, the word Altair never popped up ever again for Pertec, who was trying to cancel that product line and distance themselves from the Altair name by this point. But just an interesting side note. And finally, I'd like to demonstrate the utility for programming the EEPROM on this new board. When you run this program, you're going to run a terminal emulator on your PC as the console. This, of course, allows you to send Intel hex files over with the data that you want to program into the EEPROM. This program runs completely standalone. It doesn't need an operating system of any sort. And this means it has to talk directly to the serial port in your system to do this communication. That, of course, means it has to be customized for whatever particular serial port you might have. Now, it's very easy to do. There's just a few equates at the top of the file, and you just reassemble it for most any serial port you're going to do from back in the early days. I have one working here on the Altair 2 SIO. I've also already created one for the SOL 20 and an MSI SIO2 board. Very easy to make new ones. If you ever make one I don't have, go ahead and send it my way, and I'll add it into this folder where I'm collecting these different versions of this programmer. All right, the easiest way to load the programmer in is with a monitor that has a hex load command. If you don't have that, of course, you can still just type in a 15-byte program or so to load a binary file, and there's an option for doing that in this same folder along with these hex files in case you don't have an Intel hex loader. I have an Intel hex loader though, and so I've already got it in here, and I'll jump to it. It runs at 100, and it gives you three options: program the EEPROM or enable and disable the write lock. These EEPROMs have the ability to block writes even if the write line is connected and the write line is inserted. It'll still block the writes. You don't really need that for this board since we have the switch to actually disable the write line. However, when you buy these parts on the surplus market, there's a good chance you're going to receive them and the write lock is already on. So this will come in handy for turning that off so you can use it for the very first time. Or if you really want to, you can turn it back on. But let's go ahead and program an EEPROM. That's option 1. And it tells you to go ahead and enable the write line to the EEPROM. That's switch 7 position 3. Once you've turned that on, then you can write to the EEPROM. Let me make sure I've done that real quick. Yes, I did. Okay. And now it says send the hex file. Well, let's just go ahead and program cutter in here that we were doing earlier. Send the hex file, and there's cutter. All right, again, it's a 2K file from C1000 through C800 roughly, or exactly, whichever way you want to look at it. And it tells us here what it found in the file. Now, if I hit P to program, it's going to program it at those addresses. But right now, cutter, I don't want cutter at that address because I'm running my Altair configuration right now, not the subsystem B configuration. I have the EEPROM halves swapped. So right now, that subsystem B configuration is down at 8,000. 8,000 when swapped is where C1000 would have been here. So you can actually change that here. And so now it's going to program it from 8,000 to 8800 instead of C1000 to C800. Exact same code. It doesn't actually change the code, but it'll program it here for me. So this is a convenient way to program things, even though you may have hardware or EEPROM in the location of the PROM you need to program. By swapping halves like this, you can put it somewhere where you can safely write it. So to program it, we just hit P for program, hit return, and it's done already. So it writes very quick. This is much easier than pulling apart, digging out an EEPROM programmer, burning it, erasing them in a UV eraser, etc. So this is kind of nice. Of course, when you're all done, you're going to want to flip switch 3 back on that switch 7, and that way it's protected from then on. All right, well that does it for this video. I'm very excited to finally have this memory board. This is something that I had designed and had planned on making for at least the last 10 years or so, but of course never got around to it, kept pushing it off till tomorrow. But luckily for me, thanks to a hobbyist named Josh Bensadon, tomorrow finally arrived. He turned around and made my ideas into reality in the form of a KiCad schematic and circuit board layout. And we then took that board and did a few tweaks to it and finally sent it off and had a prototype made. I built up that prototype, did some testing and a few more tweaks, and now we have this production version that you're seeing demonstrated here today. Now it's available for purchase only as a bare board. It's very simple to build. It's not hard to get the parts. And if you want to order one, I've put a link to how to go about that in the information for this video.